Okay, hello everyone. I hope everyone's having a good day. I hope everyone had their lunch, no? Right, so I will be discussing again. I am Samantha Servo, and I will be discussing about DNA for data, Python-powered bioinformatics for solving local challenges. So our agenda for this afternoon will be these three things. Now, I will be talking about first the introduction of bioinformatics because I want everyone here to have a high-level understanding on how bioinformatics impacts us on a greater level. Also, I will be teaching you the tools and techniques so you yourself can explore bioinformatics through Python. And lastly, I want everyone here to see the parallel with the data science and bioinformatics. Later, I will talk about more, no? All right. I won't be dwelling too much about this because I've been introduced by our wonderful host na. But again, in a nutshell, I am Samantha Servo. I'm currently a computer science student. And as you can see here, I have been leading some organizations. And I have this logo here. It just means it's my personal philosophy. It's my personal brand. It's called Beyond the Vinculum, like being an outlier, exploring what is beyond the standards or is expected from us. That's just what it means. And also, I've been I've been writing about tech blogs, specifically AWS and bioinformatics, because I'm passionate with these two things. So I was writing about these blogs. You can check them later. I will be showing you later, no? And that's all for my background kasi we need the context to understand who is this girl who's going to talk about bioinformatics. It sounds niche, di ba? All right, now for the introduction. Okay, is anybody here aware or has anybody here have any idea about Philippine Genome Center? I just want to see some hands if you've ever heard about this. Okay, that's nice, no? Or how about bioinformatics as a field? Does anybody here okay, that's nice, no? Okay, this that you can see here, this website is actually the Philippine Genome Center, and they have this slogan called Genomics for a Better Philippines. It is a research unit in University of the Philippines. And why am I talking about this? Because they are using bioinformatics to impact us. Okay, they have a lot of R&D services, not only limited to bioinformatics, such as DNA sequencing, the bioinformatics, protein proteomics and metabolomics, clinical genomics, and biobanking. You can check all of them in their official website. Okay, now let's go to their two high-impact applications because I want everyone here to understand how exactly can bioinformatics help us, right? Okay, we have first of all the COVID-19 initiative, and you will be able to see here that they are able to sequence COVID-19 samples. Diba? During our COVID-19 pandemic, they have used bioinformatics, no? For what? For virus monitoring or biosurveillance. Since 2021, they've been doing this. They are sequencing genomes of different variations of SARS-CoV-2, no? Why? Because they want to understand how progressive this virus is and para alam nila, they know the response for the said pandemic. Secondly, we also have the ASF virus testing response, no? This one is for the African swine fever response. So to be able to have a response to this scenario, no, they have been detecting ASF virus present since June 2020. No? They already have 2,174 pig samples. Again, involved dito yung bioinformatics. Bioinformatics has a lot of impact. No? What is bioinformatics? Bioinformatics, in a simple sense, is data science of biology. Just think of it like that. No, we are converging two fields here. I know, no, is anybody here has any experience with data science? I want to see some hands. Data science, no? So you are aware of the process of data science. It is the same. However, more specifically, with bioinformatics, we are focusing on biological data. Okay, and they have been accredited. It means that their laboratory testing services are of legitimate quality. No? Okay, that is the high-level explanation. We already know there are two high-impact, but they are not only limited to those two. They have two high-impact applications here in the Philippines. First, during the COVID-19, and then secondly, for the African swine fever. Now, I know you want to understand that and to know how you can explore this field yourself, because personally, actually, I've been self-studying more on the biological side because I'm passionate about data science. So most of the time, I'm studying the general side. And I've decided to learn more about biology, and you can also do it. No? We're going to be focusing on Python today. Okay, and you will be able to see here. I know a lot of things here are already familiar to you, no? We have the pandas, SciPy, NumPy, di ba? We are using this in a general sense to import the data, pre-process the data, and then gather insights, right? And I will be discussing the biology-specific application or libraries here as well. And we have other things here like the SnakeMake, which is a workflow management system that you can use, and also Rosaline, which is a platform in which you yourself can learn biology and programming, no? Specifically with Python, because Python is the most widely used in bioinformatics. All right, here, we're going to go to BioPython first. It is a library, again, specific to biology. All right, in this example, this is actually for a script for sequence cleaner, okay? We are going to remove duplicate sequences, no? First of all, what is this file, no? Is anybody here aware or has any idea what a FASTA file is? Okay, that's nice, no? FASTA file is one of the most commonly used in bioinformatics, no, for the sequences, and it has two parts. The header, here, as you can see, we have the greater than symbol here. That is the header, and also the sequence itself, no? And with this script, the goal is to remove the duplicate sequences and also the unknown nucleotides, those letter ends over there. And as you can see here from before and after, it is reduced to two sequences already, okay? Here is the script. I won't be going through too much, no, but I know that you will be able to understand. But you can see here at the top, you can import from bio, import sec.io for the input-output processing of the FASTA file. And then this whole sequence will be able to read the FASTA file and then output a clear or clean version with the removed duplicates. Okay? Right, next, we have scikit-bio. Scikit-bio is another library that you can use. It has biological sequences for the ordination methods, more specific, no, for computational biology and for bioinformatics. How about the difference of the two? Is anybody here aware of the difference of computational biology and bioinformatics? It's okay. Well, there's no wrong answer. Okay, I will explain it to you. No, they are different but a bit similar. Computational biology is more focused on the mathematical models which are applied on biological data. And again, bioinformatics is the data science in biology. All right. That's just the same as the scikit with the BioPython. You can use scikit-bio as such as a library, but it has more coverage of specific applications in biology because it also encompasses the computational biology. Okay, next, we have SnakeMake. SnakeMake, again, like what I've mentioned, is a workflow management system. And the graph that you will be able to see here is actually from a paper written by the creator of SnakeMake, because their goal is to have a sustainable data science process or data analysis process. What does it mean? No? We have three things here to remember. We have reproducibility, adaptability, and transparency. When it comes to reproducibility or silico reproducibility, you must be able to reproduce your same process on same code, same data, same environment. Because it will be easier that way, right? You won't have to do everything from scratch. You can use it again and again and modify it if needed. So there's where adaptability will come in. You can modify your process, right? Because it is important that you don't have to do everything from scratch, so you have to reproduce the whole process on a different application. It should be adaptable. And thirdly, transparency. In a general sense, I know that it is important. Everybody here know that documentation is important, right? Especially if we're dealing with biological data. That's why it is important to have transparency. Everybody must be able to validate your results by being able to trace what you've used, no? What software, what code, or environment that you are using. Those are the three things that they are aiming to consider: the reproducibility, adaptability, and transparency, ultimately leading to sustainability. This is for a sustainable data analysis process that you yourself can also use. No? It is the SnakeMake workflow management system. All right, next. I'm excited to talk about this because this is a platform that you can actually go to. Just search rosalind.com. You will be able to see this. And just a fun fact, Rosalind Franklin is actually a British chemist that has her work contributed to the understanding of molecular structure of DNA and RNA. So it is actually the reason why it's called Rosalind. No? Just a fun fact for everyone. Okay, going back here, we have 5 things going on. First, we have Python Village, in which you can learn or practice your Python. If you are coming from a biological background and you have only a bit of technical expertise, no, specifically sa programming, you can go to this section and you can practice your Python. If you are confident with your biological understanding and also Python programming expertise or any other language, you can use Bioinformatics Stronghold. I will show you later how it looks. We have Bioinformatics Armory if you want to see the tools, no, such as the BioPython, because you don't need to write everything from scratch. Remember that. You can reuse what's already existing. We have Bioinformatics Textbook Track if you want to follow a textbook type of pathway in bioinformatics. And we have Algorithmic Heights if you want to focus on honing your algorithmic understanding. Okay, here is how it looks like. No? If you're going to be solving problems just like LeetCode, no? Just think of it like LeetCode, but it is more specific to bioinformatics. We have this, and they have problems over there that you can solve. And this is an example of what I've done, no? Complementing a strand of DNA. We have 2 things going on here. First, we have the short bio lesson, so you don't need to worry. If you have no idea on what biological concept you need to know, you can refer to this. You will be able to review. It is discussing about the secondary and tertiary structures of DNA. And then you can solve accordingly. This one is an example code that I've written in Python in order to reverse, no, the complement, to get the complement strand of DNA. That's just an example of what you can do. No? They have the sample data set here so that you know what to expect, and the sample output. Next, we have the Bioinformatics Armory. Okay, listen over here. I've talked about the BioPython a while ago, right? They are teaching you the programming shortcuts. No? So you don't have to write the script on your own. You will be able to utilize what I've talked about earlier, BioPython or Scikit-Bio, whatever you want to use. This is the part wherein you will have more context about the problem, and then you will be encouraged to use existing libraries to aid your work in data analysis, specifically in bioinformatics. Okay, I've explained the tools and techniques, and I hope you have gotten a lot of idea on how you can explore this field further on your own. Now, I know everyone is excited to see how it is parallel with data science because it is so specific, right? This is specific to, it is niche field to biology, right? Okay, if you want to see the whole code source in GitHub, you can scan this and look at the project source, the code source yourself for later reference. Okay, and I just want to say this is a bioinformatics bipolar drug discovery because the target protein that I will be working with in this project is related to the something that works with bipolar. Okay, I will be telling you about that in a bit, and I want everyone to know that I've been using a guide from YouTube as well on the internet. As always, I've been using the data professor's guidance because he's actually more inclined in data science and bioinformatics. Okay, this is the same QR code that you can scan this again. Right, let's go to the workflow. We have 6 things going on here. We have 6 steps, no, to remember. It is familiar, right? Everything that I've written here, they are familiar. Because they're similar, again, to data science process. We have data collection, data processing, chemical space analysis, or it's just a specified version of exploratory data analysis. You know it, right? You have idea about EDA. Next, we have descriptor calculator dataset preparation. It is specific, pero it's just feature engineering in a general sense. It's just more specific in biology. No? We have model development and evaluation, and then conclusion. Okay? Just the same. Let's go through them, okay? Okay, first step is data collection. In this first step, you can see I have chosen a target protein. It is a norepinephrine transporter, or NET. It is related to bipolar disorder. That's why I've chosen this protein, because it works with norepinephrine, and norepinephrine is responsible. It is a chemical messenger responsible for your stability of mood, alertness, and so on. Okay, and in this part, no, I've gotten my data from the Chembel database. It is a repository that you can gather compounds, proteins, and many more. And most of the time, it is for drug discovery processes. And you will be able to see here, no, this is a notebook. I've been using Google Colab, and you can use Jupyter Notebook, whatever you want to use. You can use them, and then I have imported the library here of the ChemBL in order to access it within the notebook. And then you'll be able to see there, I've entered the norepinephrine, and I will be able to choose which protein specifically. And this is specifically for Homo sapiens, okay? Because that's who we are. Next step is data processing. Data processing has 3 steps here. I've broken it down so it is easier to digest. We have the making sure that the data is consistent. It must be consistent. It is the general rule when we are data processing, right? It has to be IC50 type. It is just a standard value that we will use here in drug discovery. And secondly, we have missing values. They have to be handled. You have to remove them if there are a lot of missing values, no? Or if it is not serving any insights. Or you can deal with it with any other method that you're using in data science. And lastly, we have compounds. They are labeled with active and intermediate. Now, I won't be going too much into this, but it just means that if it is active, the drug will work even at a small amount, and otherwise, if it is inactive, it's not. That's just what you need to know because we will be focusing on active and inactive. You'll be able to see here how I've written the code and the table. We have the molecule Chembi LID. We have the canonical smiles here. And then this is the standard value. This is the column for the IC50 that I've been talking about. And the bioactivity classes. You can see it. We have active and inactive. And now we will be able to analyze what's happening over here. Chemical space analysis is just a specified term, no? Because we are focusing on EDA. We have the descriptors. We need to analyze them for drug likeness. We have 4 things here: the molecular weight, the octanol water partition, the log P. And then we have the donors here, the bond acceptors and bond donors. We need this to assess the drug likeness of the compound. And then I performed log transformation with the data. And then we are going to analyze them. Okay, this is how it looks. Similar to the data science general process. Okay, now we have the feature engineering. Just know that paddle descriptor is used for the fingerprints for the more unique representation of each. Because in machine learning, we need to be able to fit the data. So we need to turn them into zeros and ones. And then model development, I've just used a lazy regressor for this one, so we don't need to tune each of the model individually. And in this, we have the LGBM regressor as the best model. And in conclusion, we can use LGBM regressor with the R-squared of 0.43 and 0.56 adjusted R-squared and RMC of 0.82. We can still improve this actually with more feature engineering. Kasi you will be able to see here there are a lot of not predicted as good as the others. So we can still improve this. And that is all. I've discussed the Firstly, we've learned the high-level information about how you can apply bioinformatics. Secondly, the tools and techniques and how you can use them on your own. I hope you will be able to explore them on your own. And thirdly, you have seen the parallelism with data science in general and how bioinformatics work at the same time. Okay, if you want to connect, you can scan this QR code if you want to connect with me. Let's connect to explore endless possibilities beyond the vinculum. You can collaborate with me if you want. I'm open with the networking. You can scan this and you will be able to see my tech blogs as well, my LinkedIn, so that we can connect. Again, that is DNA for Data, Python-powered bioinformatics for solving local challenges, presented by yours truly, Samantha, Vivien, L. Servo. Thank you.
All right, thank you so much for that very comprehensive talk, Miss Samantha. Now, I believe we have some time to entertain some questions on the talk, so you may raise your hand and we'll hand you the mic.
So for questions.
Okay. Okay. So, Samantha, what do you think the biggest challenge in adapting the bioinformatics solution here?
Here in the Philippines specifically or in a general sense?
I guess here in Philippines.
Oh, I think based on what I've been learning so far, the most difficult part is the lack of laboratories because actually the part that I've discussed, it is only focusing on the data science part, no, the model building part. But in that example, for example, the drug discovery project that I've done, it is only part of the whole pipeline. We still need the preclinical and clinical testing and others. So you really need to communicate with those who has the resources to work on it further. And as you can see, what I've discussed earlier, the Philippine Genomics center here, it is only one, no, as a research unit. And actually, because I'm interested in pursuing the graduate degree in bioinformatics, I've only seen one school, which is UP, who offers the said graduate degree. What I can say is there are lack of resources such as laboratories and also lack of awareness on how bioinformatics can also help us. Because as you can see, it is limited. No, I hope that answered your question.
Yes, thank you for that.
No problem. Yes.
Hello.
Hello.
First of all, I find your presentation very interesting because I'm also interested in
Bioinformatics.
bioscience. So my question is that what got you interested into bioscience?
Oh, that's a good question. Actually, I'm interested in the biology part because what I really want to do is to go to med school, to be a doctor. And I want to utilize my computer science degree before going to med school. So I realized, oh, maybe I can go to graduate school and study bioinformatics to combine both my knowledge, current knowledge in tech, and also to prepare myself for med school because I will be learning about the biology part. That's why.
Okay. Thank you.
Thank you.
Speaking about using bioinformatics to help us, what was your model trying to predict? What value was it trying to predict? And then when we have the model, what will be its impact to help us? What can you start?
Oh,
How can you start applying the model?
Okay, that's a good one. Actually, what I've been doing is to predict. It is to predict the values of which compound is more likely to be used for this specific protein. It is a target protein like what I've said, and which compound is more useful. I haven't explained further, pero what I've used kasi, during the process, I mentioned the using of descriptors, right? I've been using descriptors because descriptors are the features that you need using the rule of 5 of Lipinski. Lipinski's descriptor, it just means that there are rules that the compound must follow. If the compound violates one of those rules, then it means that this compound is not good for oral use because the drug discovery project itself is actually for figuring out which compound is better for either inhibiting or progressing the said target protein. So it is needed because of course, we are the ones who are going to ingest the said drug, di ba? So the compound must be able to spread to our bloodstream properly through oral provision or oral application. Yeah, that's it. Do you have any questions, Papa?
Hello.
Hello.
So given that the field of bioinformatics contains a lot of, let's say, sensitive data, there's a lot of governance involved with regulations, compliance, and all that. How do you navigate those kinds of challenges associated with uh, compliance and regulations when it comes to analyzing data? So, for example, when you want to try and operationalize it now, or you want to productionize your work in bioinformatics.
Okay, thank you. For that one, actually, one of the things that is important is to work with others, with other experts. Because for me, it is only for illustrative purposes and to explore the field itself. But I'm intending to work with the researchers in the future if I actually want to productionize this model. No? Secondly, there are existing databases that you can use on yourself if you want to practice. No? Actually, AWS has open data program in which there are upload data sets on S3 bucket that you can use with practicing, no, or maybe providing insights. Pero overall, because bioinformatics is a sensitive field, Ren, because of the biological data, you really need guidance from those who are experts if you want people to be able to use your results.
Got it. Thank you.
Thank you. Okay.
Thank you for the wonderful talk. No? So I'm also during my undergraduate degree, I've been studying biomathematics, not bioinformatics. So more on mathematical models for biological systems. Anyway, my question is more on the result of the model that you've.
Yep.
Um, I saw that your R squared is maybe it's more of on the statistical
Yes.
part, no. The R squared, I think, is around 0.43. And
Yes.
given that you've explained yung predictive model or the predictors and what you've been predicting, how for me it's a low
Yes.
regression score, right?
I agree.
So how would you, as a data scientist or as the analyst yourself, how would you improve on that model?
Okay. So actually, my recommendations for that is first of all to have more domain knowledge. Because me myself, I'm gonna be honest, I've been again what I've said earlier. I've been self-studying the field. I've been self-studying biology, and of course, I have my degree with me for the technical part now. But I still need more guidance with the biological part in order for me to tweak the features. So secondly, we need feature engineering more. We need to ponder more which of the features are really important, no? Because if there are features involved there that are only adding noise to the data, it won't actually give us an insightful result. And actually, I can explore more models beyond what I've explored, given the time and again the expertise. Because really need someone really need the domain expertise, not just in bioinformatics, but also the other applications of data science in any other field like financial and others. You need the domain expertise or knowledge to be able to understand what's going on. That's all.